Today we are going to discuss about the principles of transformer. Okay. So last class we seen about the applications of DC motor. Okay. So what are the applications of DC motor in real time application? Application. So the DC motor which are usually electric vehicle, mainly DC motor. Okay, electric bike, electric car, mainly usually brushless DC motor. So one of the applications then induced. Okay, water pumping. Okay, so for the robotics and for home appliances and for paying noise, so we are using the DC motor. Okay. So let's go on to this transformer. First of all, we have to know what is transformer. So what is a transformer? So transformer is a static device. Yeah, good. So it is used to transform the energy from one circuit into another circuit. What about the frequency? Frequency? That is constant or variable? Constant. The frequency is constant. So okay. And what about the main? Why we have to use this transformer? Why we have to use this transformer? What to both consider? So one is to step up the voltage or step down the voltage. Mainly the transformer is used to step up the voltage or step down the voltage. Okay. And what is the main key characteristic of this transformer? What is the main key characteristic? Compared to motor and generator. It is a static device. The motor and generator is consist of rotating part, but in the transformer it does not contain any moving part. So that is the main key characteristics when compared to the motor and the generator. Okay. So then we have to do an empathy on transformer. So can you able to see the magnetic flux line? It is visible one. Okay. So in transformer it consists of how many windings? Two windings. What is the name? Primary winding and secondary winding. So whether the primary and the secondary both are combined together, that is physically attached together. No. Then how the energy will transfer from primary into secondary without any physical contact. Okay, how without any physical contact, how the electrical energy can be transferred between primary and secondary? Induction. What induction? Magnetic induction. Mutual induction. That is called mutual induction. Faraday's law is mutual induction. Then next. Okay. So from this defined state, from this empathy, we have to define. Okay, now. So why the transformer is needed? Why the transformer is needed in the power system? We have to look why the transformer is needed and how the transformer transfer the energy from primary to secondary without any physical contact. Without any physical contact. And then what is the mutual induction concept? What is the mutual induction concept and how the voltage and the current varies accordingly? For both whether step up or step down, how the voltage get changes. Okay, like this. Okay. So this is an ideal state. So in this ideal state, okay. So this is nothing but a transformer core. The transformer core is made up of. The transformer core is made up of copper. Silicon steel. Why is it made up of silicon steel? To provide lower lag transfer, so the maximum flux will flow from one circuit into another circuit. Okay. And it has two windings. One is called the primary, it is connected with the source, and the secondary winding is connected with load. So initially, what is the step number one? Anyone? What is the step number one? Okay. So now, for the primary winding, we have to the primary winding is connected with the source, then we have to switch on. When the AC supply is given with the primary winding, so what will happen? Okay, the magnetic flux. The magnetic flux is in secondary winding. Okay, and the first step number 1, we are providing the AC supply to the primary winding. So the primary winding is getting excitation, then we start producing the fluxes. So the produced flux is nothing but magnetic flux. Then the produced flux that will be linking with the secondary winding through the transformer core. So because of an AC, it gives alternating magnetic flux in the positive direction and in the negative direction. Positive oscillator and negative oscillator. So the flux is always getting changed. That is nothing but and change in flux. So when the flux is linking with the secondary winding, at that time what will happen? What will happen in the secondary winding? Mutual induction. According to the mutual induction, the EMF is induced in the secondary winding. With the help of mutual induction principle, the EMF will be induced. Then the induced EMF, the induced voltage, that will be taken into some loads. So according to the load, we can able to vary the output voltage by adjusting the number of turns. By varying the number of turns, we can able to vary. Okay. So this is the working principle. Okay, after giving the AC supply, then it start producing the flux. The produced flux that will be transferred to the secondary winding to transformer core, and according to the mutual induction, because of the change in flux, the EMF will be induced, that will be delivered to the load, and according to the load requirement, we can able to adjust the output voltage. Transformer. Mutual induction. The mutual induction, that means the change in flux. If the EMF is induced according to the change in flux. Okay, and what is the mutual coefficient? What is the efficiency of transformer according to the mutual inductance? Percentage. The percentage of transformer efficiency. Percentage. Coefficient is nothing but 0.95. So you go for percentage, it is 95% to 99%, because according to the thermodynamics law, none of the machine will give 100% efficiency. So 1% drop will be there. So we are expecting the percentage efficiency from 95 to 99%. Okay. So in the construction, may know how many types of transformers are there? 2 types. May know names? What is 4-type transformer? How many types of transformer? 2 types. 4-type and shell-type. So okay. May know the main difference between the 4-type and shell-type transformer? Okay. So in 4-type, the windings are get separated, but in shell-type, both are mounted in the same cylinder. Okay. And what about the magnetic paths? Here, how many magnetic paths will be there? In shell-type, how many magnetic paths will be there? In shell-type, we have how many magnetic paths? Only one. And what about 4-type? In 4-type, it has only one. In 4-type, it has only one path, and shell-type, it has 2 paths. Okay, so this is the 4-type and shell-type. It is based on the low power application and a high power application. So it has only one magnetic path, it has 2 magnetic paths, so that we can use it for high power applications. Okay. So here the primary and the secondary, all the winding is made out of whether it's aluminium or copper. Copper, made of why? Why it is made of copper? To reduce the losses, because if we go for aluminium, the cost is low, and whatever the losses is high. Also, the lifespan is decreased. So always we have to prefer copper to get high efficiency and for longer life. Okay, correct. Okay, and this is the real-time application where we are using the transformer. Generating factor. In the generating factor, subtraction, that is to step up the voltage. Okay, you have to step up the voltage for the long range transmissions and for the industrial equipment and for commercial electronics like to solve the So that we are using the transformer to step up or to step down the voltage. So this can summarize. So we think what is the operating principle and the EMF equation and the components like core, primary, secondary rating are incidental and application which are used in the transmission distribution and induction home operating. So this is a very may know why the transformer won't work on DC. Why the transformer it won't work on DC. So there is no flux, there is no frequency, no change in flux. There is no change in flux. If there is no change in flux, there is nothing but stationary flux. If it is stationary flux, so the EMF won't induced. So the transformer it won't work. Okay. Suppose if I am giving, I know all those criteria. Again, even though I am knowing the criteria, I am supplying this to the transformer. What will happen? So the transformer is act as a purely resistive. The winding is act as a purely resistive. So it is unable to hold the I current. So the transformer will burst out. The transformer will burst out. Okay. So what happens to the power loss when the transmission voltage increase? If you are increasing the transmission voltage, and what about the power loss? What about the power loss? In the generating circuit, I am increasing the voltage from 11 kV to 750 or 650, whatever it may be, or 1100, whatever it may be. And by increasing the voltage, what about the power loss in the transmission line? Then the power losses can be minimized because if I am increasing the voltage, the current can be minimized. So according to the heat loss or power loss, there is something called I square R. We are minimizing the power loss. So that only we are using the transformer in the generating and substation. Generation and transmission. Okay, it is mainly to reduce the power loss. So that only we are boosting the voltage. Okay. And third one, why are transformers core or laminated? Why we have to laminate the transformer core? To reduce the eddy current losses. The main purpose of using the laminate is to reduce the eddy current losses. Okay, so this is an assessment. The core of transformer is laminated to mainly reduce eddy current losses. Okay, the EMF induced in the transformer is based on whether Ohm's law or Lenz's law or Faraday's law or Kirchhoff's law. Faraday's law. So these are a few texts. Any doubt in that?